Hello. In this video, we are going to discuss some more cases associated with vectors. Now, in the first one over here, we have to determine the vector equation of a straight line passing through a given point and parallel to a given vector. Now, in order to do that, we will consider the figure that we have over here. Now, the vector equation for a straight line simply means that we will be obtaining, well, we can consider a point on that line and we may obtain the position vector of that point. That will give us the vector equation of that line. Now, for that, what we have is we consider a point P on a line. The point P is on a straight line, and that straight line is carrying the point A. So the straight line passes through a given point and that given point is A. And also we may have a certain vector B which is somewhere, which may lie along that line or which may be somewhere else but along that direction, such that B vector and this AP line that we see over here, that will be some multiple of that B vector. That is how we predict the case of one vector being parallel to other. If that would have been the B vector itself, then the scalar that is multiplied to it, that is t, that would have been equal to 1 and we would have had an equal vector, that is AP would have been equal to B vector. But we do not have that condition over here, so we can say that it is some multiple scalar times the vector B, and that is why the line AP is parallel to the B vector. So the line AP now satisfies both the cases, that is it is a straight line and it is carrying a point a given point, that is the point has been given to us, and it is parallel to the B or the beta vector. That's not B, that's beta vector. So it is parallel to the beta vector. The point A supposedly has a position vector alpha with respect to a reference point O, which is more or less the origin. Now, in order to find the equation of that line that is associated with that line, we simply have to obtain the position vector of the point P. Now it becomes pretty straightforward, where we have the OP, which is the position vector of the point P, that is equal to the sum or the vector sum of the vectors OA and AP following the triangle law, and therefore we have the required vector equation of the straight line which passes through the point O and is also parallel to the given vector beta. Now, so there shouldn't be any confusion that it is another line OP that we have obtained, but it's not that. It's the equation that is associated with that line which is carrying both the important information, that is it has the position vector of the point A and also it has the line which is parallel to the given vector beta. So no confusions with that. We'll try one more case related to such a given phenomena, and then we'll move to a different case. Like in this case, supposedly we want to find the vector equation of a straight line passing through two given points. Now, in order to have that, we'll consider simply two given points, that is A and B supposedly are two given points, and we have a straight line that is passing through both these points A and B, and we end it, suppose, at the point P. It may continue after that, but we will keep it to the point P. Now, A has got a position vector supposedly alpha, just like in the previous case. A has a position vector alpha vector, and B now has a position vector, let us say, that is beta. The point has gone a bit further. No worries, we keep the point B to that new position. So beta vector is the position vector of the point B, and now we have to just determine the position vector of the point P, which also, due to my diagrammatic error, has extended a bit further, so we may have to rub it over here. So this is beta vector. Let me just rectify my mistake with the diagram over there so that there is no confusion. So that is the beta vector, and now we simply have to determine this the position vector over here, that is r. In order to do that, first of all, we have this, we know this value, that is AB. AB over here is going to be beta minus alpha. That's from the triangle law. But that entire line AP, that is going to be equal to some, that is obviously along the direction of that line AB. That is why it will be some scalar multiple of AB. So AP vector is some scalar multiple times of AB, which is beta minus alpha. And now we simply have to determine r vector, which is the position vector of the point P, which is along the straight line which is passing through both the given points, or the position vector of whose have been given, that is alpha and beta, the position vectors of the given points A and B. So our equation of the straight line must contain both alpha and beta vectors. So that means we'll have to just obtain OP vector, which is equal to OA plus AP, and that is simply equal to, or that is on the left hand side we have the R vector, that is the position vector of the point P, that is equal to OA here is alpha vector plus T times of beta minus alpha vector, or T times of alpha vector. So alpha vector 1 minus T plus T times of beta vector, we can write that in that form. So that is our required equation of the straight line which is passing through two given points. Now we wish to determine the vector equation of the plane through the origin and parallel to two given vectors. Now let us suppose we are having two vectors over here, one over here, and we name it as the alpha vector, and one over here we name it as the beta vector. Here's the origin. Now what we can do is we can consider a vector which is parallel to alpha, and we put it over here passing right through the origin, and it's bending a bit. Let me draw it clearly and properly for you. So there's the origin, and we have a vector which is parallel to that alpha vector, and then we have another vector, and we have that as the magnitude. Let that be equal to some times of alpha, that is k times of alpha, and this one another line which is passing through the origin, and that is parallel to the beta vector, and let that be equal to m times of beta. So now we have a plane which is made out of two sides which are obviously passing through the origin and parallel to the two given vectors alpha and beta. So all we need to do is find the resultant, or the resultant of the two vectors will do the work. So we have to take this one, and then we do the parallelogram over here. So this is k times of alpha once again, and this is m times of beta, and the diagonal over here, my bad, the diagonal over here from one corner to the other is going to give me the required vector. We name it, suppose P once again. So OP is the required vector. Let us say that is equal to R vector, and that is the equation of the vector which will be carrying both the vectors which are parallel to alpha and beta, the given vectors, and also passing through the origin. So this is k times of alpha plus m times of beta is the required equation of the vector which is in the plane passing through the origin and parallel to the two given vectors. Then next we obtain the vector equation of the plane through a given point and parallel to two given vectors. Now supposedly we consider a plane over here, and it is carrying a point. Let us say the point is A, and that A has a position vector, a certain position vector with respect to the origin. We take that position vector as alpha, and now we want the vector equation of the plane through that given point and parallel to two given vectors. Now just the previous case we had learned that if it is parallel to two given vectors, then it will be carrying, let us say the vectors are supposedly we can take it as beta and gamma. So there will be another point, we may consider another point which is so that line AP, another point is P, such that the line AP is parallel to two given vectors. Let us take the two given vectors as beta and gamma. Well, if they were given, then we would have taken as they had been given, but since we are selecting it, we can take it as we like. So now, just in the previous case, we had learned that it will be some scalar multiple of each of those vectors, and then we'll sum it up. So here we will be taking supposedly m times of beta plus n times of gamma. So this is the vector which is parallel to both beta and gamma vectors, and A is the point which is having a position vector alpha with respect to the reference point, which is the origin. So now we only need to find that position vector of the point P which is involved in all of this, like we have been doing. So this is R vector, and so R vector, that is the OP vector, is simply equal to the R vector, which is the sum of OA vector plus AP vector as per the triangle law. And so from that we have AP vector to be equal to alpha vector plus the other one, that is m times of beta vector plus n times of gamma vector. M and n are just the scalar multiples which are there because of the condition of parallel to the vectors of beta and gamma. Now in the next case we have to obtain a vector equation of the plane passing through three given points whose position vectors are alpha, beta and gamma. Now we could have proceeded in the familiar way that we know for points and we can obtain the vectors, but the problem will be for three given points. Well, they can be placed anywhere on a given plane, just like I've shown, and no matter what method that you apply, you'll always find it difficult to obtain the equation with the position vector from any third point to a reference point that you are considering, to the point P that we are going to draw or we are going to set. So it's ideal that we know that there are two vectors which are lying on this plane, that is we have the vector AB. So if you observe this B, this A over here, so from A to B we can have a vector over there, and from the point A to the point C that is over there, we can have another vector over there. Now this plane is obviously parallel to these two vectors, and when the plane is parallel to these two vectors, the line that if we have a point P now, this AP line will give us the case of the line which is, or the vector equation for the plane which is parallel to two given vectors, which is exactly the case that we had considered in just the previous case, the diagram above. Now AC, we'll have that value because C is C is having the position vector gamma and A is having alpha. So this is simply some multiple of some scalar multiple of gamma minus alpha. And also we'll have the AB that we have, that is beta minus alpha. So that line which will be parallel to that will be some multiple of beta minus alpha. So that means we can have now the position of the point P from the origin that has been considered. So from the origin to that point P, we have a vector r, that is a position vector, and then we can put this equation as r vector is simply equal to alpha, that is OA, and then we'll have the other terms coming up. So that will be some multiple, because of the case of parallel vectors, so some multiple of the AB vector. AB vector in this case is, as we can see, that is beta minus alpha, and plus n times of, that is some multiple of the vector AC, which is going to be equal to gamma minus alpha. So now this is equal to, we have the vector, that is the vector equation of the plane passing through these points whose position vectors have been provided. So r is equal to alpha, well, that will be alpha 1 minus m minus n, and then we'll have the m times of beta vector and n times of the gamma vector. So that was the required equation, or that was the required equation of the vector. So that was the required equation. We'll try some more examples and problems related to such cases in the upcoming video. So for that, stay tuned. Till then, thank you for watching.